Now that we've learned the basics, let's dive into some specifics. In this lesson, we'll learn how to run a container. What we'll be doing today is executing commands in containers on your computer. The containers will start up and run, and then shut down. In future lessons, we'll talk about starting and running an entire environment of containers, keeping them online, running in production, etc. But for now, we're just going to focus on running commands. So I'm going to switch over to sharing my screen, and we will get started with some of these demos. So the first thing that I want to show you is hub.docker.com. And we're going to look for the PHP image. Right there it is. And you can quickly see what tags are available. So you have an image, and images can be tagged in certain ways. Latest is a convention in the Docker world to pull whatever is the latest PHP container. In this case, or a node container, you'd be node:\latest. So the tag is delineated, as you can see here, by a colon, and then you have latest or ZTS bullseye, etc. And you can see there's many tags to choose from. You can go all the way over to PHP 7 or PHP 8 or PHP 5.6. There's many different tags that you can pull. Let's see if I can search for from 5.6. Yeah, so you can go all the way back to different versions of PHP with the tags, the way the PHP Docker team has tagged the images so that you can run older versions of PHP and that sort of thing. So that is the image on Docker Hub. So let's quickly demo just running that image. So here's the command, docker run is the command, and then you have a flag here, -it. So -I stands for interactive, and T stands for teletype. So it just tells it that you are in an interactive session with Docker. With this container. And then this is going to specify what image to pull, and it's going to default to the latest tag, but you don't have to specify that. That would look the same as :latest. And again, by Docker convention, it's just going to default to that. And then finally, we're going to say what to execute. So if you don't give it something to execute, it's not going to run. So in this case, we're just going to run bash. Bash is available in the Docker container, so we're going to run that in our terminal here. Notice that it's unable to find this image locally, and so it goes out and pulls the image down. It's pulling this image from hub.docker.com. And now we've dropped into bash in the PHP container. And if we sort of list out what's available there, you can see all the stuff in the root of the container there that you're in. So now once we exit this container, the container is going to stop running. And here's something important to note. We didn't specify what to do when the container stopped running, so the container, the ghost of the container, is actually still sitting around out there. If you do docker ps lists containers, and -a stands for all. So by default, ps only lists running containers, but if you do -a, it's going to say, well, here's the status exited 22 seconds ago. That container is no longer useful. And on Docker Desktop, for instance, on your Mac, Docker Desktop also exists on Windows, you can actually cheat and use a GUI interface, and you can see there's something here that's exited that isn't running anymore, and we can actually click that and just remove it, or you can run a command, docker rm, and you start typing. You're looking for this container ID right here. And you start typing, say, the first three, and as long as it's unique and there's no other containers that are stopped that start with AE3, it will remove that. And so if we list docker ps -a, you can see it's no longer there. We're doing the same thing in Docker Desktop. We can see in the containers that it is no longer there. But what we want to do is we want to auto-remove a container once we're done with it. And so we can use this flag, ~rm, and that will tell Docker to remove the container when it is finished. When it exits, go ahead and remove it. Don't leave the ghost of it laying around. So we'll run that command now. And again, we'll show what's running there, or what's listed there, and then we'll exit. And now, if we do ps-a, it isn't listed there anymore. And we can confirm the same thing in Docker Desktop GUI. Now, what is a little more useful than dropping into a command line session which you may want to do sometimes. But oftentimes what you'll want to do is spin up a container, run a command, and then spin down. Now, I'm going to use the ls command, which is probably not all that useful for most things that you would want to do, but it's a good demo to kind of demo what's going on. So we're going to use that same command up to this point, but then we're going to specify -c, which stands for command, and we're going to say, we're going to give it the command in quotes to run. So we'll grab that and we'll go ahead and enter. And you can see that it listed out the contents with the ls command and then it exited. And if we run ps-a, we can see that it is not listed there. All right, so far so good. So now what I want to do is I want to demo running the PHP Apache image. So the PHP images all come with Apache variants where Apache and PHP are both installed in the container, and we can run it. What we're going to need to do in order to do that is some port mapping. We've talked a little bit about this in our Docker key concepts, but what we're going to want to do is map some port that's available on our computer into a port that is going to be used by Apache. That's port 80 in this case. Of course, you can configure Apache to serve SSL and HTTPS with certificates and run over port 443. But in this case, we're just doing the default for the container, for the image, and that's going to be port 80. And so we're going to specify a port mapping. So that's done with the option -p. And we're going to go use 9000 on the host. So when I hit localhost 9000 on my Mac, it's going to hit port 80 inside of the container, and then that's going to be where the website is served. So let's go ahead and run that command. So notice again, it's not able to find php:/Apache, and so it downloaded it, and now you can see that it's running it and it's waiting there. So let's go ahead and let me pull a window over here. Oh, and I'm going to cheat. Because I have Docker Desktop, I can just click this. It shows what port it's running on. And that's good. We're actually getting Apache. Now, we have nothing to serve. There's nothing for Apache to serve in this container. There's literally no index file or anything. And so that's why you're getting the forbidden error. But we are seeing Apache, and we're seeing an Apache response. So that's good. So let me go ahead and close that window. And we're going to exit out of here. And we can see the container's gone. So what we're going to do, I've already kind of decided on just going to run a simple example, index.php. So I'm going to go into that directory. Did I remove the directory? Here we go. All right, so, and then I'm going to create an index.php file and edit it in Vim. As you can see, I've already created the file because I prepared this example, and I'm just echoing hello world. That's all we're doing here, just to show that it's running. And so let me get out of there, and let's run the command. Now, in order to run this command and have it use the files, we need to do what's called a mount. We've talked about this in the key concept. So if you're not familiar, the pwd command stands for the working directory. Print working directory is what pwd stands for. So that's going to get the directory that we're in right now. So that's just, and basically going to expand it right there. And then we're going to put it where Apache is looking for its files. In this container, it is var www HTML. And so we're going to run PHP Apache. And here we go. We're running it now. And let's go ahead and open that page back up. And yay, you can see the hello world example right there. And just to show, because we've mounted the volume into the running container, when we edit it on our computer, it's also going to be edited in the container. So we want to go to the PHP example, vi index.php, and we will add just something that you can see. So let's save and close, and let's refresh this. And because we edited on the computer, and because we've mounted that directory into the running container, any changes we make on the computer are reflected in the running container. And so you see that that's reflected there. Okay, let me get out of here, and we'll stop that container. And one other example that I want to show, just so you can see the usefulness of containerization. I use something like this. I usually script it and put it in my dev scripting for my project. But if I need to use a specific version of Node to install dependencies or whatever, then I will use something like this to do that. So in this case, I've dropped in this example, I've dropped in a package.json that will not install in newer versions of Node. It's just not compatible. It's using stuff that's not compatible with newer versions of Node, but it will run in Node 12. So we're running an older version of Node, which isn't installed on my computer, but we can use the magic of Docker to do it. So you can see this command looks pretty familiar from what we did above. We're getting the current working directory and putting it in the app directory. Here we're using we're telling Docker to use a working directory of apps. So when we start the container, it will be in the app directory. That's so we don't have to do any cd into the directory or whatever. It'll just be in that directory. And then we're going to run the Node 12 image. And then in bash, we're going to give it a command to run yarn. I prefer to use yarn. You could do npm install, whatever command you wanted to run here. So let me get into the right directory. And let me go ahead and run this command here. We'll paste that in there. And notice again, it couldn't find that image, so Docker takes care of that for you. If the image exists, it'll pull it down. We know that the Node 12 image exists, so it's going to pull that down, and it's going to extract it into an image format it can run, and then it's going to run yarn install. Now, I didn't prepare this demo very well, so let me remove node modules and run that again. So now you can see that it's fetching those packages and installing them. And we'll give it just a second here to complete that. And there you go. And so I'm going to list the directories. There's the node modules directory it just created through the yarn install process. So that's running Docker containers on your local computer. Of course, in future lessons, we will explore how to create projects and containers that run and keep themselves running with Docker Compose and how to get things out to production. So stay tuned.